Hey everybody, today we're going to be making a video showing some of the differences between inductive and deductive reasoning. So to get us started, we're going to be using inductive reasoning to demonstrate that the sum of any two even numbers is even. Inductive reasoning uses examples. Now, how many examples do we want to use? Although it's not really important, I typically like to use 3 examples. You could use 5 or you could use 10, but the truth is it really doesn't matter as long as you're trying to pick some good examples. So let's test this out. We start off with some easy ones and we'll say 4 plus 6. And that equals 10, which checks out. That's even. Maybe we'll try a trickier one and we'll say 120 plus 44. And that equals 166. Also even. Check. And we can even get really sneaky and we can be like -8 plus 14. And that equals 6. Also even. Having done 3 examples, we might be able to make an educated guess at this point that this is most likely true. Now you could think really hard and see if you can come up with a counterexample. If you could come up with a counterexample, it would only take one counterexample to absolutely end this. And that's why I say 3 examples is good. You could give 100, but you're probably just going to keep guessing about the same style of guess. This is most likely true. But let's take a look at what deductive reasoning does. In deductive reasoning, we're not just demonstrating if it's likely true, we're going to prove that it is true. And here's how we're going to do this. Suppose we have any 2 even numbers. And instead of just guessing 2 even numbers, we're actually going to use variables. And we're going to say 2x and 2y. Wow! How does that show that that's an even number? Well, any even number can always be written as the product of 2 and some other number. So if you were thinking of 30, which is an even number, that's just 2 times 15. If you were thinking of 6, that's 2 times 3. So x can be any integer. X can be any integer at all, and if we multiply it by 2, we get an even number. The reason why we didn't use 2x and 2x is because that would mean it's the same even number, and we want to show that we could have any 2 even numbers. So this is any possible even number, 2y is any other possible even number. And you could have used a or b or any letters that you want. It really doesn't matter. Take the sum. Take the sum. And we get 2x plus 2y. Well, that's not real exciting, but that's what it is. That's the sum. At this point, we're going to use a general rule to show that that is even. And this general rule is, if a number can have a 2 factored out, then it is even. And really, that's what we used up above here. 2 times any number must be even. So we're going to check to see if this 2x plus 2y is even if we can factor out a 2. So can we divide this nicely by 2? It turns out we can. We can factor out a 2. And it leaves us with x plus y. We can! Exclamation mark. Therefore, this is true for all possible answers. We're so awesome. And then I always end these with a QED, and that's what you get to write if you've done a proof correctly. And if you watch any of my other videos, I brag about that, and I always make sure to put a little smiley face in there as well. That's deductive reasoning. We've proven this. It's not just a couple guesses. We've shown that if you take any even number and any other even number, add them together, that this little answer here can always have a 2 factored out, which proves that it's always even. Let's do one more. Scroll up here, and this time we're going to use inductive reasoning to demonstrate that the sum of any 2 odd numbers is even. All right, well, let's try this out. Any 2 odd numbers. This uses examples. Inductive reasoning uses examples. Is it 100% true? No. Can we make a quick and probably decent educated guess? Absolutely. 3 plus 7 equals 10. That checks out. 15 plus 17 equals 32. Okay, that checks out. Negative 5 plus 17 equals 12. Okay. That also checks out. And we tried to mess with this, and you could use bigger numbers. You could use like 101 and 99. I can make another example here. 101 plus 99. It equals 200. It's still check. The trick is to try to come up with a counterexample. Try to think of an example that breaks it. If you can't, this is most likely true. Now, maybe someone else will come along and give us a counterexample. Hooray for them. That's great. This is most likely true, but we can't be 100% sure. Let's scroll down and try this deductively. To deductively show this, we have to begin by, suppose we have any 2 odd numbers. Aha! We just saw this game. But how do you write an odd number? Well, if an even number is 2x, we can say that an odd number is always 1 more than any even number. Because if you think of any even number, like 10, and add 1 to it, 11, you'll get an odd number. If you're thinking of the even number 50, add 1 to it, you'll get 51. It's an odd number. So the way we represent odd numbers deductively is with a 2x plus 1. To get my other odd number, 2y plus 1. And it's just a different variable to show that it's any 2 odd numbers. Same as before, take the sum. When we take the sum, we're going to have 2x plus 1 plus 2y plus 1. And this equals 2x plus 2y plus 2. If you understood the first example, you should be giggling right now, because in order to prove this is even, I hope that you remember, if this is even, we can factor out a 2. When you look at this, 2x plus 2y plus 2, can we factor out a 2? Yes, we can. 2 times x plus y plus 1. We factored out that 2. We can! Exclamation mark. Therefore, the answer is even for all possible answers. Q, E, D, happy face. Once again, by using deductive reasoning, we haven't just given some examples, we've proved it for all. We've picked any 2 odd numbers, we've added any 2 odd numbers together to get any possible answer. We've shown that no matter what answer we get, even using variables, we can factor out a 2. which means that for every possible answer, the answer will always be even. And that's how we use inductive and deductive reasoning.